All right, we're going to talk about something that's a huge deal in AI right now. It's this new research that tackles one of the biggest, most fundamental roadblocks we've had for years: how to get an AI to understand truly massive amounts of text.
I mean, just think about it for a second. What if an AI could read, say, a whole novel, like all of War and Peace, and not just summarize the plot, but understand the deep thematic connections from beginning to end? Right now, that's pretty much science fiction.
You see, even our most powerful, cutting-edge AIs, they all hit this context wall. They have something that works like short-term memory, and when you try to stuff too much information into it, their brains kind of just overflow.
And this chart here, it tells the whole story. Look at what happens. As the prompt you give the AI gets longer and longer, its performance, its ability to reason correctly, just completely tanks. It literally falls off a cliff. You can't just stuff a whole library into its brain and hope for the best. It just doesn't work that way.
And there's a perfect name for this problem: context rot. I love that. It's exactly what it sounds like. The AI's memory of what it read at the beginning starts to decay and rot away by the time it gets to the end.
So yeah, that's the big challenge we're facing: the AI's reading problem. How do you get it to process a library-sized document without its brain turning to mush?
Well, the old approach was basically brute force. Just, try to build a bigger brain and cram everything inside. But the new approach, the one we're looking at today, is a complete rethink of the whole problem. Instead of forcing the AI to memorize the book, what if you could let it treat the book like an external library that it can just walk around in and reference whenever it needs to?
And this brings us to the hero of our story, a brand new paradigm called Recursive Language Models, or, RLMs for short. And this isn't just about a bigger model. It's a fundamentally smarter way of using the AIs we already have.
Probably the best way to get this is to think of an RLM as a senior researcher, right? A top professor doesn't read every single page in the library for a project. No way. They look at the assignment, check the index, and then they delegate. They send out junior assistants to read specific chapters and come back with summaries. The RLM is that senior researcher, and those junior assistants are just copies of itself. So this whole idea of recursion, of delegating work to clones of yourself, that's the secret sauce. But how does it actually work under the hood?
Okay, so check this out. The magic is that the long document isn't fed directly into the AI's memory. Instead, it's loaded on the side, almost like an open file in a computer program. So the AI doesn't have to remember the whole thing, it just has to know how to read from the file using code. So here's the play-by-play. First, the whole document is just sitting there. Second, the main AI writes a little bit of code to take a peek. It asks, okay, how long is this thing? What's at the beginning? Third, and here's the key, it programmatically carves out a chunk and calls up a junior assistant, another instance of itself, to analyze just that piece. Finally, it just waits for all its assistants to report back, and then it stitches all their findings together into one final answer.
And that process, inspect, delegate, and synthesize, is the engine that lets an RLM tackle these enormous problems. It's like how you'd eat an elephant, right? One bite at a time. And the results? Oh boy, the results are stunning. Look at this side by side. On the left, that's a standard, super powerful AI model trying to handle a long, complex task. Performance just collapses. But on the right, that's the exact same model, just using this new RLM framework. It stays strong. The performance is totally rock solid.
I mean, the researchers put it pretty bluntly themselves. The base model's performance degrades significantly, while the RLM maintains strong performance. It's about as clear a result as you can get. And get a load of these numbers. For one particularly nasty task where the AI had to find and pair up related info scattered all over a huge document, the base model scored 0.1%. 0.1. That's a total failure. The RLM version, 58%. That isn't just an improvement. That's the difference between something being impossible and something being actually doable. And what's really wild is they even took a smaller open source model and just gave it a little bit of training on how to think this recursive way. Its performance on these long document tasks shot up by an average of over 28%. That's a massive jump just from changing the strategy, not the underlying model.
So the data is pretty undeniable. This recursive approach is a game changer, but the story gets even cooler from here. Because here's where it gets really interesting. This RLM framework doesn't just let the AI read more text, it actually forces it to develop entirely new, smarter strategies for reasoning about that text.
For example, the AI spontaneously starts to learn how to use coding tools to do a hyper-specific search for a keyword instead of reading the whole document. It's like a superpowered Control F. And it even learns to be an efficient manager, batching similar questions together before sending them off to its subagents. It's actually learning intelligent research habits all on its own.
And get this. Another incredible emergent skill is that these RLMs can produce answers that are way, way longer than their own memory limit. They just have their subagents each generate one piece of the puzzle, and then the main AI stitches it all together into one long, coherent final report. It's brilliant.
So let's just quickly sum up the key takeaways here. First, RLMs basically shatter the context limits of even our most advanced models. Second, their performance scales so much better as tasks get harder. And maybe the biggest point of all, this points to a whole new way to make AI better. It's not just about building bigger models, but about teaching them smarter strategies for thinking.
So why does this all matter? Because it unlocks a whole new class of problems that AI can now tackle. We're talking about analyzing a patient's entire medical history, debugging millions of lines of code, or conducting legal discovery across thousands of documents.
And it leaves us with this really fascinating final thought. We've spent years trying to make AI brains bigger and bigger, but maybe the real breakthrough isn't a bigger brain. Maybe it's about teaching the AI the fundamental human skill of how to break down a huge problem and delegate the work. Perhaps the next leap isn't just about thinking, but about managing thought itself.